Hi guys, some time ago somebody asked me to make a tutorial on how to bond or join or tie two parts together. And in that case, I showed you a couple of options in which we use tie constraint. And in that case, we had to join two surfaces together using tie constraint in the interaction module. Now I have another user has come up with a challenge that what if they don't want to use tie constraint? Can they still join the parts which have different properties? And there is no tie constraint. So if there is tie constraint or any other contact properties you define, then there will be implications on the computational time. So in today's video, I will try to show you another way of how to bond or join a component or two components without using any constraint or contact properties. So let's jump into it. Okay, we are in ABAQUS. I will quickly go through it. I will create two parts. So part one is 3D deformable solid extrusion part. And I will create a rectangle, let's say starting from 0 to 0, 0, and it goes up to 10. Let's make it 10, 20, 10. So basically there will be two parts of 10 by 10 by 10. So that's what I have done here. And then I will say done. Then I can give a depth of 10 as well. So you will see it's a long part as it was in the previous video as well. The link to the video is also given on the top, so you can go there and watch that video as well if you are interested in looking at what I did previously. So this is the component, and now I want to divide them into two components and then assign different properties. So that's what I'm going to do, which is a simple way. First thing I will do, I will just create a kind of a partition, and for partition I need a cutting plane or a datum plane. So for me the easiest thing is to create a datum plane. I will say create a datum plane along YZ plane or on the YZ plane, and then I will give a distance of, let's say, 10. So you see it's in the middle, and now you can cross it, and I will say now partition based on the datum plane, and then I will select the datum plane and create partition. So now I have two partitions, and next thing I will do is I will go to the property module. And so in a way I have divided it into two small components, but still the properties we haven't assigned, so we have to assign the properties. So I will first create material 1, and I will call it, let's say I will give it the properties as steel properties, maybe this, and then 0.33. Again, I'm using some arbitrary properties, and then I will define material properties 2, and in this case I will give, let's say, aluminum properties, so 50, I don't know, I'm just giving some random values, and 0.3. Isotropic, everything is isotropic. So just to show you how you can assign different properties while not using any constraints or any tie constraints or contact properties. So now you have properties. I will create two different sections. The first one is section 1, homogeneous, and in this case I will select the material 1. Then I will create another section. I will call it section 2. And in this case, I will select the properties of material 2. And now I will assign for the first portion. Now it's not a two separate part. It's one part, but it's a different portion. And I can assign different properties there. So I will assign property of section 1 to this section. And then this portion, I will assign section 2. Once I assign it, they look very much similar. If you want to see your properties are assigned properly, you can have a color coding, and here you can color code the component based on the material properties. So now if I do that, then you can see your one part has two different properties based on our assignment, and it's assigned properly. The rest of the stuff is very much the same. You just apply the boundary conditions and the loading conditions, and obviously do the simulation, and you will get the same results as I did it before. And this will definitely not require you to go to the interaction module, where you have to first bring the part here, the assembly module, and now if you go to the interaction, then you don't need to use this tie constraint. In that case, if you remember, we had to do a tedious job of creating two surfaces first for first part and second part, and then use this tie constraint. And obviously this way you can more efficiently run your simulation without defining any contact properties. So I hope you find it useful. If you have any more questions or if you need any more tips on your simulation, improving simulation time, efficiency, or accuracy, then please comment below and I will definitely come up with a short video or a reply as soon as I can. Thank you very much and have a great day. Bye for now.